Hi there, jumping into Unit 5 today with adding and subtracting matrices. So let's cover a few definitions just to get us started. Sometimes you want to combine matrices to new information. You can combine two matrices with the same dimensions. Meaning if there are 2 rows and 3 columns in one matrix, there needs to be 2 rows and 3 columns in the other matrix in order to be able to add them. And the way we do that is by corresponding elements. So corresponding elements are simply elements that are in the same position. So if it's in row 2, third column, the same element in row 2, third column on the other matrix, those are called corresponding elements. I've got a good notes concept down here, but I think I want to flesh this out with an example. So keep that handy to look back at. But let's take a look at an example because I think it's going to make better sense to you. So let's take a look at this problem, this first one that I have. Oh, I've got a good note there that I want to make sure I'm paying attention, that this helps me with a quick check. So it says to find the sum or difference. So you can see, let's check the dimensions. This has 2 rows and 3 columns. This has 2 rows, 3 columns. We are good to go ahead and add. So remember, we're going to add corresponding. So if it's in row 1, column 1, I'm getting to add it. 5 plus 1 is 6. Go to row 1, column 2, add these two. 4 and 1 gives me 5. 3 and 1 gives me 4. See, I'm only adding the ones that are in the same position. 1 and 1 gives me 2. Negative 2 and 1 gives me negative 1. And 6 and 1 gives me 7. And now I have added them. Now, I do realize that second one had all 1s in it, so it made it a little bit easier. Let's look at example number 2 then to do some subtraction. Okay, watch the order because you and I know order matters when we subtract. And watch our locations. So 2 minus 2 is 0. 1 minus 3 is negative 2. 2 minus 2 is 0. 1 minus 3 is negative 2. 2 minus 2 is 0. Remember, at corresponding elements, 1 minus 3 is negative 2. So if you'll notice, I was using my fingers to watch my location. Matrices are all about details. So make sure you take your time. If you're like me, you're talking that through. 3 minus 1 is 0 minus 2 is, and I do that because it keeps me focused. I don't lose track of where I'm at in the matrices. So something to think about there. Okay. Look at example 3 here. We're doing the same thing, but we've given the matrices names now, okay? So we've told you that this matrix is C and this matrix is D, and we're going to subtract C minus D. So let us do that with our corresponding elements. So I've got 1 minus 5 gives me negative 4. Watch the order. 2 minus 1 gives me 1. Negative 3 minus 0 gives me negative 3. And 1 minus 2 gives me negative 1. Okay, pretty good with that. Just a little bit of notation change there with number 3. Let's look at 3B. One was written in at the last minute. That's okay. It's still a good problem for us to take a look at. Before I jump into the matrices, I want to look at this equation. It says find B if A minus B equals C. little algebra here, right? I'm going to say A minus B equals C. I'm looking to solve for B. So I'm going to go ahead and I'm going to add B to both sides. I'm going to try to get that B positive. So I see those cancel. I've got A equals C plus B. Now I need the B by itself, so I'm going to subtract C. So I know now that A minus C equals B. Now I know what I'm doing with these two matrices. I'm going to be subtracting A minus C. So let's take a look at the order there. So A minus C. I think I'm going to write this one out because it's got some negatives going on. A minus C. And I've got A minus C. Then I've got A minus C. Ooh, I can see where I could get these signs mixed up really fast. Okay, let's do row 2. A minus C. A minus C. And A minus C. Now I wrote this one out because of all the sign potential. Man, I could make some mistakes with those signs. I'm going to go through and change these subtractions to plus by changing the sign of the next number. I'll make it a little bit easier on myself. I think I can do the last two. Okay, so now I've got -3 plus 2. That gives me -1. Then I've got 1 plus 2 is 3. Then I've got 0 plus 1 is 1. -4 plus 3 is -1. 8 minus 4 is 4. 10 minus 5 is 5. Okay, that was a little tricky one, right? It had some notation, a little extra equation work up here. Then we had to watch those negatives. Man, those are like, you have to be really careful with your details there. That's why I wrote them out in hopes that I wouldn't really have trouble with that. Okay, one more problem for this section, and that is to find the values of all the variables. Okay, so something you need to know, when you have two matrices that are equal to each other, that means that each element's location must be equal to each other. So for instance, row 1, column 1, these must be equal to each other. So I know that 4C equals 2C plus 5. Each element's location must be equal to each other. So we can solve here just by subtracting 2C. I get that 2C equals 5. So I know that C is 2.5. Okay, let's go to the next location. So I've got row 1, column 2. So that would be 2 minus D equals 4D. So in this one, I'm going to solve for D by adding D to both sides. I get that 2 equals 5D, so D is 0.4. Okay, next location, let's do row 1, column 3. So we get that 5 equals G. That's pretty easy. Look at row 2, column 1. We already know that -3 equals -3. Look at row 2, column 2. So I'm told that H equals -1. Now I'm looking at row 2, column 3. I've got that 2 equals F minus G. 2 equals F minus G. Now lucky for us, we already know that G was 5. So we'll make that substitution. And we can tell that F is 7 then. And I'm slowing down on my highlighting here. There we are. Okay, so now we're in row 3, column 1. Nice, but 0 equals 0. Row 3, column 2, -4 equals a -10. I'm sorry, -4c equals -10. So you can divide there and see that c is 2.5. And then finally we get that 15 equals 15. And we've identified all of the variables here. Nice work with this. I hope you're enjoying the matrices, and I look forward to more work on it.